Welcome to qnawire.
Okay, in this problem we have air at standard temperature pressure. We're given its mean free path. It's about 9 times 10 to the negative 8 meters. And we are asked to find the collision frequency for these molecules in this ideal gas. So this may be perceived as cheating, but in problem 49, we derived an expression for the frequency, which is F equals 16 times the pressure times the radius of our particles squared times the square root of pi over mkt. This was derived in the previous problem, 49. And so from that, we can actually get everything. If we assume that the mass of air, which we've done in a number of problems in this chapter, is about 29 times the mass of a proton, and we have standard pressure temperature, we can do this rather easily. We also can assume that the radius of our air particles is about 1.5 times 10 to the negative 10. This has also been done numerous times in this chapter, so I think it's fair game. So just using this result, we can get this frequency. Plugging in our numbers, we have 16 times standard pressure rather, 1.013, 10 to the negative 10 to the 5 Pascal. That's standard pressure. 1.5, 10 to the negative 10 meters squared. Radius, root pi over 29, 1.66, 10 to the negative 27 kilograms. The Boltzmann constant, 1.38, 10 to the negative 23. It's getting messy. And finally, our standard temperature, 293 Kelvin. Okay, doing all those calculations, we end up with a result of about 4.8 times 10 to the 9 hertz, which we can approximate to be 5 10 to the 9 hertz. So this would be 5 gigahertz. And that's it. Kind of a shortcut, but I think it's valid.